Here are the block of codes for the heat map and the scatter plot, joint plot, and finally the Pearson correlation. Okay, my presentation is going to be about the weather data analysis, which is a Python 1 project with Sami. My name is Dema. I'm going to present it. Okay. First of all, I want to present special thanks to Mr. Sami Lau, our splendid tutor, for this wonderful journey with Python. I also want to thank Ms. Minikosh Singal, my mentor, for her unwavering support throughout this journey, and also all of Paper Airplane team, especially Rama, for being there all the time. Thank you all. Okay, so the content of my project is going to be divided into 6 sections. The first one is going to be, I'm going to talk about the data selection, why I've chosen this data set, and the variables that are within the data set. Also, the meaning, just a brief explanation of the variables. And then I'll move on to data cleaning. How do we clean the data so that there won't be corruption formats when I'm doing the code? And then I'll move on to data exploration, which is basically like questions and I need to answer them. And then I also use visualization to present the answers as graphs and pictures. Yeah. And the fifth section is going to be about statistical analysis. Basically, I'm going to present or show the correlation factor between the variables in my dataset, how they are correlated strongly or weakly. Is it positive correlation or negative? And final step is generalizing all the previous steps with functions. I could use classes, but I'm more like familiar with functions, so I've done it with functions. So there's no section actually, because all of the previous sections are already generalized in this presentation. Okay. Okay, so the data selection. It's a weather data set for the year 2012, and it's a time series data set with per hour formation, meaning that actually the data set changes over time, and the step between each data set is 1 hour between them. And it's about the weather condition at a particular location. There's no specified location for the dataset because when I search for the origin of it, I found out that the dataset was made for practice for data analysis. So basically, it's not like a naturally occurring dataset. It's just an artificial one. Okay, and it's available as an Excel file, and we are going to analyze this data using pandas, pyplot, numpy, and seaborn. Okay, so here's just like a picture of the table of my dataset. As you can see, here's the variables or the parameters, which are the date and time, the temperature measured in Celsius, the dew point also measured in Celsius, the relative humidity, and the wind speed measured in kilometers per hour, and the visibility in kilometers, the pressure measured in kilopascals, and there's the weather condition as a description, is a word description. Okay, so for the date and time, as you can see, the format here is a little bit tricky and consumed a lot of time because it's the first time I'm dealing with such a format. We can see here, let me use my laser pointer. You can see here, there's the month and the day and the year. So there's 3 types of information, and there is the hour and the minutes. So it's like 5 types of information we have here. So it took a lot of time for this to be analyzed. And the other things are generally numbers, so there's no problem. But here, weather are words, so we have to deal with strings here. So yeah. And the volume of the dataset is about 9,000 rows and 8 columns. Okay, so just to tell you guys about humidity, which is the measure of amount of water vapor in the air. Relative humidity is just a proportion or a ratio of the amount of water in the air in relation to the maximum amount of water vapor, which is the moisture. Actually, when the relative humidity reach 100%, meaning that the amount of water has reached the maximum amount of water in the air, meaning you will see that there's a condensation process happening. So you'll see a dew point, see a dew on the leaves. That's when you reach the dew point, which is the temperature the air needs to be cooled to in order to achieve relative humidity to 100%. So moving on to data cleaning. Okay. So here's the block of code I've used for data cleaning. As you can see, I defined it as a function. There's the head of or the heading of the data set, and there's the columns. Here is the cleaning part where I'm defining as not a number columns. There is the function for the cleaning. From lecture 7 that was presented by Mr. Sami. And there's the function called insert. So if it's like a Boolean function, the answer of this function or the outcome would be true or false. So if there's not a number value, if there's any, it will assign it to a list. And the same for the rows, but the rows are defined as indices. There's the columns, but the rows are indices. And not a number rows. There's just a little bit of adding here. Axis equals 1. Basically because the any in general, it takes axis equals 0 for the columns. So if I'm going to use it for the rows, I have to define it equals 1. Just little things. And there's short, this is just shifted a little bit down. So there's dot to list, and if there's another not a number value, it will assign it to a list. And then here's the answer here, or the outcome for this block of code. As you can see in this data set, there's no not a number value. The data is already cleaned and organized. You can see there's an empty list here and an empty list here for the columns and indices, or for the rows. So moving on to data exploration. Data exploration, actually I've divided it into 2 parts. We could do the data exploration for sure for any variable there is in the dataset, except for the weather condition, because it is a string of words. So for data exploration, we have the temperature. I've chosen a variable, which is the temperature, and another variable, which is the wind speed. So what I'm going to explore is like a question: what is the mean temperature for each month in 2012? And I have another question: what is the highest and the lowest temperature in 2012 with the corresponding date and time? And the same questions I could present for the wind speed variable. Okay, so here's the block of code for the function of I called it explore temperature, and the df is the like the symbol for the data set, and x here is the variable for date and time. I wrote it as a string because there's the dash here. It caused a lot of problem. I couldn't write it like this one, so I wrote it as a string. And we have the y defined. We take the temperatures in Celsius column from the df dataset. And here, basically, the code explains like a search function. Like I'm searching for the month ranges. In January, for example, the ending of the January is 31 of January in 2012. At the time is 23 p.m. or 23. I'm sorry, in general. So in this month ranges list, I'm searching for the ending of each month. And the beginning of each month is going to be the ending of the previous one. For example, for February, the beginning is going to be the ending of January, and the ending of February is this time. So I wrote it as a let's say a for loop. So for I in range, the length of the month range. So this is the list. I'm using the from the beginning to the ending. For example, if there's 12 elements here, so it's going to be from 0 to 12. And starting from index 0, index 0, I'm sorry, because the first data, which is assigned to 0, is going to be the beginning of January. So the beginning of January, the start index, I'm sorry, it will be taken from the date and time column. And the ranges be from I minus 1, which is, for example, for this, I'm going to take the beginning of the previous one. That's why I wrote I minus 1. And the index starting from 0. And the ending is going to be I at the corresponding month. This is the ending because I have the ending here, and here's the ending. All of them are the endings. So there's no need for minus 1. And the mean temperature is going to be throughout this month, is taking the Y, which is the temperature column, starting from start index, and finishing at the end index, and taking the mean. And finally, we are going to call it a monthly mean temperature, and we're taking the month temperature. Mean temperature. And there's another block, a little block code I add, because when I finished here, actually, the thing that happened, the result came out as mixed up data. I couldn't actually understand the outcome. So what I did, I added a little bit of code just to organize it as a table, each month with corresponding mean temperature. So it's just a little bit of organization here. Like I assigned it a new data frame here. I'll show the results so you could understand the meaning. Okay, and the other question is finding the maximum and minimum temperature here throughout all of the year. The previous one was only for each month. I'm finding the average or the mean. Here I'm finding the minimum throughout the year and the maximum. Okay, so here what I'm going to do is finding the index maximum. I'm going to find it for the X and Y because I want the highest temperature with corresponding date time, so that Python wouldn't only give me the highest temperature alone, it would also give me the corresponding date and time with it. And this is the format that I spent a lot of time just figuring out what should I do. And it turns out I could write it like this because it's month and day and year, hour and minute. And the same exactly like this, I copied this block of code exactly as it is for the minimum, just changing from max to min. And I'm going to return, just to give me the result, the monthly mean temperature df, which is the previous one, the format date from previous one, and here the maximum value from here, and the format date from here. Also, I could have written it as format date, which is exactly the same. But here's the result after printing them. As you can see, as you can see, here's the result as a data set. That's what I have meant earlier. As you can see, there's the month and the average temperature of each month here. And you can see here the date and time with the maximum temperature is this date and time. And the corresponding temperature is 33 Celsius, and the same for the minimum. And I did exactly for the wind speed. I've used the exact code block, just changing from here the Y column was the temperature. Now here the Y column is the wind speed. The X column is the same, which is date and time. And you can see the results are organized the same. Now moving on to data visualization. I'm going to use a bar chart, line chart, and pie chart. bar chart just to visualize the previous data frame for the mean temperature of each month and the mean wind speed for each month. So just taking the result from the previous step here for bar chart. As for the line chart, it's just a temperature, general temperature variation throughout the whole year. And for the pie chart, here we present a new idea entirely, just to like find out the frequency of the weather condition, like how many days was it sunny, how many days was it snowy, and etc. Okay, so here's the bar chart for variation of the average temperature and wind speed of every month. As you can see, we also defined it as a function. This is the user input. This is what the user is going to input, and here's the block of data code. I'm sorry. So the user is going to choose the data frame that they want to do a bar chart for, and they define the X and Y column, and they can name the X-axis and Y-axis, and they can put the title for the plot. The figure size, I could put it as a default, or I could put it as like optional here, so the user could put it. But I've chose it as a default because like 10 was good enough. And for the data frame, I'm sorry. For the data frame, this is the X column and the Y column, which could be any X and Y in the table, whether it's temperature, wind speed, humidity, whatever. And the X level, Y level title. This is the rotation, just because when I like printed the result without this line of code, the words were very near each other. They were so I just did a little bit of tilting. I will show what I mean by this. And I added a grid just for the sake of like knowing the the levels at each Y column or Y value and for X value. And there is a show of the plot. So here's the user input. For example, I want to use the monthly mean temperature F, which is the previous one that I've defined, taking the month and mean temperature in Celsius and naming the X and Y, and there's the title name, and the same could be done for the wind speed. As you can see, here's the result. Here's what I mean by tilting the naming, as you can see, because the words are a little bit long so that they won't mix up in each other. And here's the Y-axis, here's the X-axis. As you can see, there's the variation of the mean temperature of each month. And here's the same for the wind speed. And moving on now to the line chart for temperature variation throughout the whole year. The same, we define a function for the plot line chart. This is the user input. And here what the user have chosen to input. They chose, for example, a date and time and temperature. This is the X label, the X-axis label, Y-axis label, and the title label. Here's the result. As you can see, there's a lot of variation because we are dealing with 9,000 data set. So there a little bit spiky, a little bit of the spikes we can see, or actually a lot of spikes we can see on this data set. And finally, for the data visualization, we are going to deal with pie chart. And here the step was a little bit tricky too, because I will tell you why. But here we have the block of code, and actually we'll define the function here, the data frame, column, and title, and the the counts we are taking, because what I'm doing here is counting how many times like for example, the sunny or the snowy weather is appearing in the dataset. So we are taking the counts here, the value counts, and then we are going to sum them, the sum of the counts, yeah. And here, actually, I've added let's say three line of code. Here is just to solve the problem if I'm having, for example, weather frequency of weather condition that is less than 100%. There's a lot of them, so they formed like they mixed up the pie chart. So what I've chosen to do, actually just taking the ratio of the counts to the total counts that is the greater or equal to 100% to show, but for the ones that is smaller than the 100% is going to be summed and called other. Just for the small ones, I'm just going to combine that portion, combine it, and call it a other. And here, the decimals, I want just one decimal after the dot, and just like decoration, shadow equal false, and the figure size. And there is the plot called title, in case if the user haven't used a title here, so there won't be an error. And there's show the plot. Here's the user input. They have taken the weather column and called the pie chart weather conditions. As you can see, here's the result. This is the other, as you can see, combined of all the weather condition that is less than 100%. I'm sorry, lesser than 1%. As you can see, the mostly cloudy and mainly clear are dominating the weather condition in 2012. Now you're going to move to statistical analysis. Statistical analysis, I'm going to use heat map, scatter plot, and join plot, and finally the Pearson correlation factor. For the heat map, I'm going to use it to find the relation between all variables, and for scatter plot, I'm going to use it for finding the relation between two chosen variables, whatever they are. And for the join plot, I'm going to find the relation between two chosen variables also. And lastly, for Pearson correlation calculation, here is not a graph, just calculation of the correlation factor, and it's going to be also between two chosen variables. Okay. Here are the block of codes for the heat map and the scatter plot, join plot, and finally the Pearson correlation. For the heat map, as we can see, we are now calling on using the seaborn library, which is a statistical library for the heat map. And this is just a specification of the heat map that I'm going to use. I didn't add it as a user input just so that, for example, the user won't be like confused as what to choose. So I add them in the block of code here. And yeah, this is the for the heat map. Yeah, there's I've chosen two decimals after the dot, just so it will be a little bit clearer than one decimal. And the plot title, which is correlation heat map. And then for the scatter plot, here the user, since we can choose any two variables, so there's a X column and Y column, and the title is none. If there's no title, here we are using the seaborn again, and we are taking the data frame X equal X column and Y equal Y column. If there's no title, just insert the title so that there won't be an error if the user haven't inputted a title. And then we'll move to join plot, exactly the same for the other ones, so I won't explain anything further. And here which is the Pearson correlation. Actually, that was suggested by Mr. Sami. He told me for weather dataset, it is advised to use a Pearson correlation. And for the heat map, actually, it was suggested by Nina. She told me just find the heat map for everything and then choose two variables depending on that result. So this is the Pearson correlation block of code. We can see we can choose any two variables that we want and the relation between them. And this is just taking the correlation coefficient for x and y, and for this is 0 assigned for the x and 1 assigned for the y. Okay, so here's the user input. They've chosen the correlation for the heat map, and there's correlation matrix for the x and y, just taking the correlation between these two variables, and then we are plotting the heat map for this correlation matrix. And then we are moving to finding the Pearson coefficient between two variables in the dataset, which is df between x and y here. And we are printing just the title here and the correlation here taken between x and y. And then for the scatter plot, the same taking for the data set and x and y, naming of the title. And for join plot, the same for the scatter, just taking data set, x and y, and the title of the plot. Just a little bit of information for Pearson correlation test between two variables. Actually, Pearson correlation measures the strength of association between two variables, which is known as correlation test. And what we are using here is parametric correlation because we are measuring the linearity between the variables. For example, if the result is 1, that means there's a linear relationship between the two variables. R, or the relation coefficient, takes value between -1 and +1, which is like proportional or inversely proportional relation. And if R equals 0, that means there's no correlation at all. It can be applied to ordinal variables, meaning that you can use it, for example, for dataset that are numbers. There's like a defined gap between the dataset. For example, we can use it for the weather conditions, which are just words or like list of words or names or something. So you have to use it with numbers. And the sample should be used at least, for example, 30 data, just for good estimation. The more data, better estimation. Outliners can be misleading. This is not the case for our dataset. For example, if there's sometimes the ending of the dataset could confuse the with the like just like the outlines of the dataset sometimes get the estimation makes the estimation bad. Yeah, just and not the case for our data. Okay, so here are the results. This is the correlation heat map for all the variables that are in the dataset, except for the weather condition, again, because it's a list of words. And here, because of when we look at the correlation heat map, we can see, for example, there is a 0 here between the wind speed and the visibility. So there's no correlation at all between them. And we can see here again, because it's wind speed again with visibility. And here we can see, for example, a really strong correlation, nearly like it's nearing 1 between dew point and temperature. So what I've done, depending on this heat map, I've chosen to actually focus on these two variables, which are dew point and temperature. So I've taken, again, the correlation heat map between just two of them. we can see also I've calculated the Pearson correlation coefficient between them, and it turns out this number, which is very close to the one mentioned in or shown in the correlation heat map. And finally, here's the joint plot and the scatter plot. I've again chosen the temperature and dew point depending on the heat map for all the variables. We can see it's like nearly linear relationship between them. We can see it here and here in the joint plot. And then finally, here are the references that I've depended on. I depended mostly on Sami's lesson 7 or lecture 7, which was titled Introduction to Data Analysis. I've taken like some block of codes and I've edited them and used them in my project. And also I've used 2 references for Pearson correlation. And the dataset, this is the source of the dataset. And thank you very much for listening.